The first programming languages looked like assembly languages. With assembly, you have to tell the computer exactly what it needs to do at every point. You have to tell it which memory slot to store data in and which line of code to go to next. This is full imperative programming. You have to describe every step you want to execute. Naturally, the first higher-level programming languages were also imperative. These languages were a little more readable than assembly, but the paradigm for writing code was the same. The developer had to tell the computer what and how it should execute the logic. Then around the 1960s, computers started becoming more powerful, and people realized that we could shift some of the cognitive load to the machines. Instead of telling the machine what to do, what if we could just tell it what we want and let the underlying system figure out the steps to get it done? Thus, the declarative paradigm was born. Some of the first declarative languages were Lisp, SQL, and Prolog. Instead of telling the machine to loop through each item and then print each one, we just tell it what we want to print. Most modern general-purpose languages have capabilities of both built in. Let's use Dart, one of the most beautiful languages out there, as an example. To write imperative code, you must tell the computer what to do, step by step. Let's say you want to print all the numbers in this array that are greater than 3. The imperative approach would be to tell the computer what to do at each step of the process. First, loop through all the numbers in the list. Then check if each number is greater than 3. If it is, add it to the filtered list. Finally, print the filtered list. The declarative approach tells the computer what outcome it wants, and then lets the computer do the cognitive load of figuring out how to do that. Let's take the same task of printing numbers greater than 3, but using a declarative approach. For this, there is only one step: to print a list of all the numbers from the array that are greater than 3. Usually, a declarative approach will have fewer lines of code, since it's just telling the computer what outcome you want. The code also reads closer to the English language. So that's the key difference between imperative and declarative programming. With imperative programming, you tell the system what to do, step by step. While with declarative, you tell the system what outcome you want. Given the lighter cognitive load necessary to write declarative code, most modern frameworks are referred to as declarative UI frameworks. For example, in Flutter, you write the code for the UI using widgets, and you declare these widgets in a tree-like structure that corresponds to how you want the app to look. You write what you want to see. Previously, you would have to go through each step of the process of creating the component, setting its properties, and then adding it to the view. However, with these newer frameworks, only the UI layer is declarative. A fully declarative language seems unreasonable, since a step-by-step approach is necessary when writing back-end logic. After all this talk about declarative and imperative programming, maybe it's AI that is the ultimate declarative abstraction layer. With AI, all the cognitive load is shifted to the machine. Anyways, if you enjoyed this video and are interested in Flutter, check out this video next.